Hello everyone, today in this video we'll be discussing the super important questions of AI BCS515B. And when I say super important questions, it's not like the most repeated ones because VTU has been giving different questions. Also this previous year this subject was the hardest paper, so we need to be prepared. Whatever VTU gives, we need to be able to write it in the exam. Okay, so for that I have included the questions which are from the previous year paper, as well as the makeup paper, as well as the model paper, as well as from the previous schemes what has been asked. Okay, so but this is a bit lengthy video. Okay, why? Because you need to know more things. Okay, if you know more things, you'll be easily able to write more things. Okay, all you have to do is just watch this video. Okay, you need not go and learn something separately. Okay, you just need to watch this video with attention and focus. Okay, take a pen and paper and I'll be telling you in between some things you need to note down and write. That will help you in the last minute revision. Okay, so without wasting more time, let's get started. If you want the PDF of this, DM me on Instagram here. And before starting, please do like and subscribe. It helps me make more videos like this. Let's get started. The first module's first question is definition questions. The first one is intelligence. What is intelligence? What is rationality? What is logical reasoning? Okay, intelligence means you have a knowledge, okay, what you need to do, and you understand the environment, and from that you take some action, and based on the action you will get the result. It was a good action or a bad action, and apply those results as reasoning to solve problems and achieve goals effectively. This thing, if an agent does it is called as an intelligent agent. Okay, next one is rationality. It means whether you are doing it right or wrong. Okay, that is the thing which is rationality. It is a property of an agent that ensures it selects the action that maximize expected performance, the actions which maximize performance that it will select based on rationality, based on available information, percepts, and its knowledge of the environment. Logical reasoning is the process of deriving valid conclusion from a set of rules. Like logic rules will be there. Based on that rules you will be deriving some answers. Okay, that is called as logical reasoning. Next one is examine the AI literature to discover whether the following task can be solved by computers. This means there are four tasks given to us. Whether this task can be performed by AI or not, that we have to analyze. First one is playing a decent game of table tennis. Okay, can AI play table tennis? For that, two things are required. First, AI needs to have a program which understands the rules of table tennis, and second, that program has to be integrated in a robot who can make the movements of hand. Okay, and move from one place to other place. These two things, if it is done, that means it can play a decent game, but as of now it is just partially solvable. Robots can play competent ping pong, but fully professional adaptive play is not yet widely achieved. Okay, next is discovering and proving new mathematical theorems. Okay, there are few AI tools which are currently doing it, but it is not doing up to the limit which the human mathematician do it. Okay, because human mathematician can understand few other concepts which AI cannot grasp based on the environment. Okay, so it remains limited. It is also partially solvable. Computers can assist and sometimes independently prove theorems within the formal system, but broad autonomous theorem discovery is still emerging. Okay, because there are some factors which AI might not take into consideration, which we know we have to take into consideration. Okay, that's why it is still partially solvable. Next is giving competent legal advice in a specialized area of law. Suppose that you went to a court and instead of the judge, what is sitting there? A robot is sitting and AI is sitting there. That is possible or not? That is possible, but it is not fully like independently it can give the legal advices, because some things like ethical responsibility, contextual human judgment, professional accountability, awareness of jurisdictional nuance still relies on humans. Okay, AI can support, but it cannot independently practice law, so this also remains partially solvable. Next one is performing a complex surgical operations. See, one place is a doctor, one place is AI. Whom you will be trusting more? Obviously you will be trusting doctor more, right? Because AI still it's advanced, but it is a non-living thing. It can make mistake, it can go wrong, and it has biases. Okay, so it can sometimes have um, means hallucinate also. So because of those reasons we cannot still trust AI as much as we trust doctors. Okay, so it's also partially solvable. This much things you have to write. Okay, next, implement a simple reflex agent for a vacuum environment. Run the environment with this agent for all possible initial dot configurations and the agent locations. Record the performance score for each configuration and overall score. What does this mean is there is an environment here, and some places there is means dirt is there, and some places there is clean. Okay, and we put a robot here which will detect wherever the places dirt is there, it has to clean it. Okay, and then also we have to record performance score for each configuration and overall score, how much it has scored. Okay, so we will be considering the vacuum environment description. Vacuum world consists of two locations, A and B. Each location can be clean or dirty. Agent can be located in A or B. Okay, actions can be suck, means take out the mop. Left or right you have to move, or don't do anything. Loop means don't do anything. Okay, no operation. Next, performance measure. +1 for clean square per timestamp. per time step, and -1 for each action. Means if an action is wrong, it has to go -1. If it is correct one, if it has to give +1. Okay. And simple reflex agent, how it will be, its rules would be, if it is dirty means suck the dirt, if it is in A, move right, if it is in B, move left. That's all. Okay. Now agent program pseudocode, how it will be, if we see the simple pseudocode, simple reflex agent percept, and percept status, if it is dirty then suck, if location is A then move right to B, and if it is on B, move left to A. Okay, like that you have to write the pseudocode. After that, the possible initial configurations, there are two locations, so there can be 2 power 2, which is 4 dot configurations. So totally configurations it would be 8. If you find out the whole combinations, it will be totally 8, 4 for each, so it will be 2 are there, 2 for the 8. Okay. Now environment is evaluated over 2 time steps. Okay, means 2 times, first step, second step. Now the agent location, first 4 locations are for A, next 4 locations are for B. Now A can be dirty or it can be clean. Okay, when A is dirty, B can be dirty, when A is dirty, B can be clean, like that. Again, when it is clean it can be dirty, when it is clean it can be clean. So you got the point, right? So we are getting here totally 8 combinations like that. And once it is A is dirty and B is also dirty, what you have to do, you have to suck and turn to right, because you want to clean B also. If this is dirty and this is clean, we'll suck and move to the right, because we don't want means we don't want to get stuck in A itself, so we'll be moving to the right anyways. Okay. Next, if it is clean and dirty, it will be going to the right then sucking, and if it is clean and clean, it will not do anything, it will move to the right, then it will move to the left. Okay, because it will not stay stuck at any point. The options are right or left, that's it. Okay, like that for B also it is the same thing present here. Now the overall performance score would be 16, and the average performance score would be, how many operations had happened, 8 operations, 16 by 8 is 2. Okay, so this is the record of the score record. Okay, this also you have to write. So conclusion is, the simple reflex agent successfully cleans all dot configuration in a 2 location vacuum environment. However, it lacks memory and cannot optimize movement. Means it does not know if the previous one is clean or not. Okay, it has done the cleaning and it has gone, but it does not remember if it is cleaned or not. Okay, so it cannot optimize the movement, making it inefficient in larger or more complex environment. In this environment, only 2 steps were there here. It was A and B, so it was just right and left. But what if it is a grid in which there will be up and down also? So in that case, it will be not useful. Okay. Next, is AI science or is it engineering or is it neither or is it both? Okay, let's understand. Artificial intelligence, can we consider it as a science? Yes, because studying the principles of intelligent behavior, it helps understanding learning, reasoning, perception, and decision making. It develops theoretical models and algorithms and explores questions like how intelligence can be represented and achieved by machines. So it is in a way contributing to the scientific domain. So that's why artificial intelligence can be considered as science. What about engineering discipline? It can also be considered as engineering discipline because it helps to design and build intelligent systems, develop practical applications. What we need to solve, any problem would be there, how we can solve the practical applications is there for AI, and it is efficient, scalable, and real world constraints are present. Okay, so it can be considered as engineering discipline also. So the answer is both. Okay, it can be considered both as science and engineering. Next is write a pseudocode agent program for the goal-based and utility-based agents. Okay, goal-based agents, it selects action based on current percepts, predefined goal, planning, and searching to achieve a goal. You are at point A, you want to achieve go to the point B. This is the goal. Okay, so it will observe its current percepts and it will move towards the goal. That is the goal-based agent. Okay, so function would be goal-based agent, and the state would be updated based on the percept. Percept means at one point of time what are the factors present. Okay, so goal test state is equal to true. If it is goal is reached, don't do any operation. If it is not reached, take a plan and take an action. Okay, and return the action, what is to be done in that particular point, whether you have to go up, right, left, or down. That is the plan, and action means going that and doing that. Okay, whichever the final decision is, so that is the action. Based on this we will be reaching the goal. That is goal based agent. Utility based agent means evaluating possible outcomes, maximizing a utility function, and handling trade-offs and uncertainty. Means it will evaluate which is the best outcome, and whatever is risky it will try to avoid it. Okay, so the code is as follows. For each we will be having a percept, and the percept will be updated based on the state, and action should be whatever the possible actions are there. Which is the best action, initially it will be null. What is the maximum utility, it will be initially minus infinity. For each action we are predicting the result and then calculating the utility. Whichever is the maximum utility, that we will be returning. Okay, returning the best action. Okay, so A goal-based agent chooses action to achieve a specific goal, whereas utility chooses the action that maximizes overall utility. Next question is explain four approaches to AI in detail. The first one is acting humanly. Okay, means in Turing test, what happened is there was a person who was Alan Turing in 1950. He put a man here, put a computer here, and there was an interrogator, and both of them, interrogator was giving the questions to both of them, and he was receiving the answers. But he does not know which one is man, which one is computer. Based on that, he was getting answers, and he tried to identify which one was a man, which one was a computer, and it was observed that he could not identify it properly. Why? Because it is mostly accurate and similar. We cannot differentiate between AI and human. In at least today's times, it has become very difficult. So that only the AI should act humanly, okay, such that we should not be able to identify if it is a human or computer. Okay. Next is thinking humanly. They have to calculate and do the experiments or whatever the problem is, solve it according to the perception of human, how humans should be solving it. Okay, that is thinking humanly. Thinking rationally means the way in which what it is going to be thinking, it has to be in a rational way. It has not to be irrational. For example, Socrates is a man, all men are mortal, therefore Socrates is mortal. Now if AI comes and says Socrates is a man, all men are mortal, Socrates is immortal, that is a wrong conclusion, right? So that's why it has to think rationally. It has to be trained in that way. The loss of thought, how humans think, in that way it has to be trained. Okay. Next is acting rationally. Rationally means it has to have whatever the output it is giving, that has to be a rational one and correct one. Okay, it should not give the loss outcomes, and it should give the outcome which maximize our benefits and achieve our goals. Okay, it helps to achieve our goal. The rational agent is the one that acts so as to achieve the best outcome, whatever is possible. Among that, it has to choose the best one and give. Even if it chooses the second best one, it is a useless agent. Okay, it has to choose the first best one. Okay, that one. So these four are the approaches of AI. Next, with the help of block diagram, explain how agents interact with task environments. Okay, how do you interact with task environment? Suppose that you are in a classroom, okay, and the teacher has called you to solve a problem on board. Whether you will be sitting there, or you will come there and you will go out of the class, or you will come there and start saying a joke, or you will go there and solve the problem. What you will do? Based on that, you will be evaluated, right? Whether you are a stupid person or you are a sane person, right? If you go and solve the problem in the board, you are a sane person. Rest all cases, you are a stupid person. So in that way, how human will be deciding what is to be done and not to be done. It evaluates what is the outcome of each action. If I take this action, what is the outcome? Based on that, it will take the best outcome approach, right? Like that only the agents also do. They will be analyzing and seeing what if it does, what it will be going to get. Okay, and it interacts with the environment through the sensors and actuators. Okay, so like human has eyes, ears and other organs for sensors, and hands and legs and vocal tract for actuators, means you will be sensing the things from these organs and you will be taking actions from these organs. Like that only robots might have cameras and infrared range for sensors and various motors for actuators. Like for example, the machine, if you press a button, the machine will be picking up some objects. That picking up operation is done by a motor, and that is called as an actuator. Actuator is nothing but it will be performing the action. Okay, AI will be performing an action based on the actuator. Okay, and sensor means just sensing what is to be done. Okay, like temperature sensor. So the block diagram would be as follows. This is the sensor and this is the percepts, and the actions will be done on the environment. From the environment, you will be getting some perceptions that will be provided to the agent through the sensors will then evaluate what action is to be taken, and the actuators will be performing those actions in the environment. Okay. Next is briefly explain the properties of task environment. Okay, properties means how it becomes different types of task environments. Okay, it can be either fully observable or partially observable. That's the first property, which is observability. Fully observable means agent sensors can provide complete information about the environment state. Partially means it provides incomplete one. Deterministic or stochastic. Deterministic means it has been completely determined, and what its action is going to be, it is sure of. There is no options left. It has to do only one thing. That is deterministic. Stochastic means it involves randomness and outcomes are uncertain. It tries to learn and then take an action. That is called as stochastic. Episodic and sequential. Episodic means each agent action requires independent of previous actions. Okay, each action which is going to be performed, it is not dependent on the previous action. Sequential means what action has been done previously. Based on that output, you will be taking the next action. That is called as sequential. Static versus dynamic, the environment does not change while the agent is deliberating, whereas in dynamic the environment may change during the agent's decision making process. Discrete versus continuous, the environment has finite number of states, means whatever is to be done that is finitely defined, and continuous means it has continuous states, actions or time, and it keeps on changing. And single agent versus multi agent, one agent operates in the environment, multiple agents interact and possibly cooperatively or competitively work together. Okay, that is multi-agent. So what is the definition of artificial intelligence? It refers to the simulation of human intelligence, okay, in machines that are programmed to think, learn and perform tasks. Okay, this much is also enough. Okay, this much. And explain the foundations of AI in detail. Okay, so AI has been discussed in different sectors. Okay, so what are those sectors you'll be seeing now? Okay, the first one is philosophy. In philosophy, understanding the nature of knowledge, reasoning, and intelligence, AI is means the discussion of AI had started very long back. Okay, in philosophy, in mathematics, it is used for formalizing logic, probability, and computation. Okay, in economics, it is used for the decision making. Okay, and neuroscience, it is used for understanding the structure and functioning of human brain. In psychology, to understand the human behavior. In computer engineering, to design hardware and software. And in control theory, we use for regulation and stability. And in cybernetics, we use for the study of communication and control of machines and living beings. In linguistics, we use to understand the language structure and meaning. So these are the things you need to write in the foundations of AI. Okay, don't miss this question, it's a repeated one. Moving on to the second super important question, which is what is PEAS? Okay, PEAS, they can ask for different types. Okay, so I'll be discussing what is PEAS. PEAS is nothing but performance, environment, actuators, and sensors. Okay, and you need to write few more points regarding this one. Okay, what is performance? Performance means how well it is performing. Whatever the task it's needed to be performed, is it performing accordingly or not? That is the performance measure. Okay, and the environment. Environment means that object in where it is. What are its environment? What are the surroundings of it? Okay, that is called the environment. Actuators is anything but the things which are used to make the changes in the environment. Okay, like for example, if we see the taxi driver, the things which is used to make changes to a taxi are steering, accelerator, brake signal, horn display, etc. Okay, and sensors are nothing but which sense the changes and make some changes. Okay, which senses some changes and triggers some functions. Okay, that is called as sensors. So piece is PAS for the various system is given below. They can ask you for any of these system, like for the taxi driver they can ask you to write the PAS. Okay, so for the taxi driver the performance measure will be safe, fast, legal, comfortable trip and maximize profits. So a good taxi driver is the one who has all these qualities. And what is the environment in which taxi is present? The roads, other traffic, pedestrian, customers, these are the environment, these are the things and the place which is present. And the actuators are the following, and the sensors are camera, sonar, speedometer, GPS, etc. Okay, like that they can ask you for the medical diagnosis system. What is a good medical diagnosis system? A healthy patient and reduce costs, that is the one which is having a good medical diagnosis system, right? Environment will be patient, hospital and staff. Actuators will be display of questions, tests, diagnosis, treatments, referrals. Sensors will be keyboard entry of symptoms, findings, patients answers. Okay, like that there are for the other ones as well, you can go through it. Okay, moving on, we have the third super important question, which is define agent. Explain three types of agent in artificial intelligence. What is an agent? Agent is an entity capable of perceiving its environment. Okay, agent is nothing but it's a robot which is able to understand what is in the environment of it. Okay, by using sensors and acting upon it using actuators. Sensor will sense it and actuator is used to take action. Okay, to achieve specific goals. Okay, three types are simple reflex agent. This will just respond to some reflexes. Okay, it is simplest agent. These agents select actions on the basis of the current percept. Okay, ignoring the percept history. Whatever is the current action is happening, based on that action, it will do some reaction. Okay, model-based reflex agent. This is the most effective way to handle partially observability is for the agent to keep the track of part of the world it can't see now. So in this type of agent, what happens is it will have some history of whatever has been encountered. Based on that history, it will try to react for the current situation. Okay, so updating the internal state information by the time goes requires two kinds of knowledge to be encoded. First is we need some information about how the world evolves independently. Okay, the information about the world. Second is information about the agent's own action is needed. By using these two knowledges, it is easy to train the model so that it will react in new situations. Third is goal based agent. This has a particular goal and will take actions which will make it reach that goal. Okay, that is what is called as goal based agent. Moving on to the fourth super important question, we have differentiation. So it means some terms are there we need to differentiate. Okay, so let's go through it one by one. Fully observable and partially observable. If the agent has complete information about the environment, it is the fully observable. If it is having incomplete, it is called as partially observable. Single agent will have single agent. Multi agent will have what? Multi agent, right? Deterministic and stochastic. Deterministic means next state is fully determined, which from one state which next state is going. Stochastic means it involves randomness. Okay, it's not specific. Static versus dynamic. The environment does not change in static. If environment changes, it is dynamic. Episodic and sequential. Each agent decision is independent. That is episodic. Okay, and sequential is it is dependent on a previous set of decisions. Okay, discrete and continuous. Environment consists of finite set of states. It's called as discrete. Continuous means it has continuous states which is changing with time. Okay, and known versus unknown. Agent knows the rules of the environment. It is known. If it does not know the rules, it is unknown. Okay. Moving on to the module 2, we have the first question, which is the definitions. And what is state space, search node, transition model, and branching factor? Okay, so state space is a set of all possible states that can be reached from an initial state by applying all possible sequences of action in problem solving environment. So initially we are in state 1, and from state 1 we have got some actions a1, a2, a3. If we apply those actions, and after that also some actions are there which we apply, which all possible states we go, all those combination of states possibilities, that is called state space. Okay, search node is a data structure that is used in search algorithm that represents a state in a search tree along with additional information such as parent node, action taken, past path, and depth. Okay, means search node is the middle node. During the searching we will be going through many nodes, right? The middle node which we will be going, which has the information of the parent node, action taken, path, cost, and depth, that is called as search node. Okay, next is transition model. It defines the relationship between state and actions by specifying the results that occurs only when action is applied to a given state. Once an action is applied to a given state, there happens to be a transition. Okay, that model which defines all such transitions is called transition model. Okay, branching factor is the average number of successor nodes generated from a node in a search tree. In a search tree, one node can generate how many nodes? That number is called as branching factor. Okay, next is give a complete problem formulation for each of the following. Choose a formulation that is precise enough to be implemented. So first one is the coloring graph. Okay, in coloring graph what happens? You have to color a graph such a way that only four colors have to be used and no two adjacent regions have the same color. Means no two spaces together should have the same color. It should be different colors. Like that, four colors only we have to use in whole graph. Okay, so what should be the state space? It would be the all possible assignment of colors to the region of the planar graph, where each region may be uncolored or colored with one of the four colors. Okay, it can be uncolored or it can be colored. Initial state, all the regions of the graph are uncolored. Okay, initially all are uncolored, then we will start coloring it. Okay, action is assign one of the four available colors to an uncolored region, ensuring that no adjacent region has the same color. And transition model, the result of an action in a new state where the selected region is assigned the chosen color while all the other region color remain unchanged. Okay, so transition means whichever space we select and apply the color, that space only should get changed with that color. The other colors should remain the same. Okay, that is a transition model. Goal test, all regions are colored and no two adjacent regions are sharing the same color. Two rules are there. In order to successfully say that the planar graph has been colored, all the regions should be colored, none of them should remain empty, and no two adjacent regions should share the same color. Path cost, each coloring action has a uniform cost. Total cost equals the number of coloring steps. How many steps are required to color the entire graph? That much would be the cost. The next one is monkey and bananas problem. Okay, it's very simple. There is a room. Inside the room there is one monkey. Okay, and the monkey's height is 3 foot. Okay, and the room's height is 8 foot. Okay, and at the top of the room there are some bananas. Monkey wants to get the bananas. Okay, but there are two movable, stackable, and climbable foot high, 3 foot high crates. Okay, two crates are there with 3 foot. Okay, now the monkey must obtain bananas hanging from 8 foot ceiling using two movable, stackable, and climbable 3 foot crates. Okay, so state space would be monkey's position and height, which all possible positions and height of the monkey can be there, and position of the two crates, whether the crates are stacked or separate, whether the monkey has the bananas or not. These are the possible configurations or the combinations which are possible. Okay, and initial state, monkey is on the floor, crates are on the floor at arbitrary position, crates are unstacked, and monkey does not have the bananas. Actions: move the monkey to a location, push a crate to a location, stack one crate on top of another, and climb onto a crate and stack or stack crates, grab the bananas. Okay, so this would be the actions. Transition model: each action updates the state by changing the position, height, or configuration of the monkey and crates according to physical constraints. Goal test: monkey has obtained the bananas. Path cost would be each action has a unit cost. Total path cost would be the number of actions performed. How many actions we perform, that much would be the cost. Okay. Next, we have to prove that the following statements is true, or we have to give a counterexample. What it says is breadth first search is a special case of uniform cost search. Okay, means uniform cost search is there, right? And inside that one specific example, if we take for a specific particular number like that, okay, if we do or particular pattern, if we take, we'll be obtaining breadth first search. Okay, we have to prove that, or we have to prove otherwise. Uniform cost search is a special case of A star search. Okay, so the first one, BFS is a special case of UCS. Okay, how it is? Statement: breadth first search is a special case of uniform cost search. Proof is uniform cost search expands the nodes with lowest path cost. Okay, means in uniform cost search, whichever has the lowest cost with the path. Okay, see, three paths are there. Whichever path has the lowest cost, that will be taken into consideration. And BFS expands on the shallowest node. Okay, means the outermost node. After that it goes to innermost node. Okay, like that. Okay, so first all the shallow nodes are explored. Okay, if all step costs are equal, for example cost is equal to 1 for every action, then path cost g of n would be depth of the node. Means how much would be the cost, that much means how many nodes are there in one path, that would be the total cost of gn. Okay, ordering of nodes by lowest path is equivalent to ordering the nodes by shallowest depth. Okay, means if we try to see, if we arrange it based on the lowest cost should be in the topmost place, so that bfs will be taking that into consideration. That is a special case of uniform cost search, where each of the lowest cost is taken into consideration initially. Okay, therefore, under the condition of equal step cost, uniform cost search behaves exactly as the breadth first search. So this is the formula or the pattern which is applicable for breadth first search. Okay, BFS is a special case of UCS. Okay, next, UCS is a special case of A star search. In uniform cost search, what happens? In A star search, what happens? It selects the nodes for expansion based on the function g of n plus h of n, where g of n is the path cost from the initial state to node n, and h of n is the heuristic estimate of the cost from n to the goal. Means, see, if this is a start and this is the end, in between there is a node, I know what is the cost of this, but I estimate what would be the cost of this based on the cost of this. Okay, like for example, if there are three locations a, b and c, I know I have to go from a to c, but a to b it cost me 20 rupees, b to c is also almost that much only, so it might cost me 20 rupees petrol. So I will be estimating that. So first one is g of n, second one is h of n. Okay, so one we know, one we estimate. Based on that combination, we will be calculating the total cost. So if heuristic function is chosen as h of n is equal to 0, means it will go off from here, just f of n is equal to g of n. That is exactly as uniform cost search, because in uniform cost search we know all the costs of the nodes are uniform, means it is same. Okay, so uniform cost search is a special case of A star search, where the heuristic function is 0. Okay. Now, list and define four phases of problem solving process. Okay, so how a problem is solved. First, to solve a problem, set a goal. Okay, what we are trying to achieve, that you need to know. If you don't know what you are trying to achieve, then nothing will be achieved. Goal formulation is the process of defining the desired objective or goal, so that the agent aims to be achieved based on the given problem. Okay, and problem formulation. Formulation involves defining the problem in a precise manner by specifying the state space, initial state, actions, transition model, goal test, and path cost. Okay, if you define the following things, then the problem formulation will be completed. Next one is search the state space to find the sequence of action that leads from initial state to the goal state. Okay, and final is execution. Once you have done all the planning, then execute it. It's as simple as that. Okay, next, explain how a search problem can be formally defined. Illustrate the same for vacuum world problem. Okay, in vacuum world problem, we'll be trying to clean up the area. Okay, how do we clean up the area? For that, we have to define the whole problem. There will be states. The state is determined both by the agent location and the dirt locations, where the agent is present, where the dirt is present, based on that. Okay, so it can be totally 2 into 2 square. Okay, agent is in one of the two locations which might or might not contain dirt. So there are two possibilities, and there are four combinations present which can be clean or not clean, 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 not clean, not clean, like that. Okay, so totally 8 possible word cases could be there. This is the same example we have discussed in the previous module also. Initial state would be any state designated at the initial state. Actions are three: left, right, and suck. Okay, and larger environments might also include up and down. Since we are considering an environment of just two spaces, we'll be taking only two here, right and left. Okay, transition model. The actions have expected effects except moving left, the leftmost square, and moving right, the rightmost square, and sucking in a clean square having no effect. Okay, so see, three things are not possible. You cannot move right of right side and left of left side, and if something is clean, you cannot make it more clean. So those three are the limitations. Apart from that, all the rules are valid. And goal test, this checks whether all the squares are clean or not. Path cost would be each step costs one, so the path cost is the number of steps in the path. Okay, and this is the diagram we need to make. Next, explain different metrics used to evaluate an algorithm's performance. Okay, so how do you measure the performance of a problem solving? What are the metrics used in measuring the performance of problem solving? Okay, so first one is completeness. Is the algorithm guaranteed to find a solution, or when there is one, or it can miss also? Second is optimality. Does the strategy find the optimal solution? Means among the many solutions, does it choose always the optimal solution, or sometimes it can choose the non-optimal one also? Time complexity, how long does it take to find a solution? Space complexity, how much memory is needed to perform the search? Okay, and the typical measure in the size of the state graph would be v plus e, where v is the set of vertices or nodes, e is the set of edges or links. Okay, between the nodes the links will be there, right? How this node is connected to the other node, based on that it is be the size of the state space graph will be defined. Okay, and complexity is determined in the term of three quantities. The first one is b is the branching factor. From one node, how many nodes are coming? D is the depth, means from one node you can go till what level depth, and the m is the maximum length of any path in the state space. Time is often measured in the terms of number of nodes generated during the search, and the space is measured in the terms of maximum number of nodes in the stored in the memory. At one point of time, how many maximum nodes you store in the memory, that is what is getting into consideration for calculating the memory. Okay, because memory has to store that much. Suppose that there are 1,000 nodes. At one point of time you are storing only one node, so the memory required would be just one, not 1,000, because one will be used and after that you will be replacing it. But if you are using 100 nodes also, but at a point of time you want to store 50 nodes, the memory would be 50, even though it is 10 times less. 100 is 10 times less than 1,000, right? But still the memory would be higher. Okay, explain the PSA. Okay, PSA is also repeated one. Problem solving agent. What is a problem solving agent? Explain with an example of 8 puzzle problem. Also we have to mention the components and well defined problem in the 8 puzzle. Okay, so what is a problem solving agent? Problem solving agent is an agent that solves problem. Okay, very simple. Agent is a problem solving agent is an agent which solves the problems. Okay, it is goal driven AI that uses logical sequence of steps to identify the solutions to the specific problems. Okay, so 8 puzzle problem is shown here. We have to arrange it in this form: 1 2 3 4 5 6 7 8. In this way we have to arrange. Okay, this is the starting state. Now which blocks to move and in which sequence it has to be moved, that is the problem here. Okay, so some things are defined here. These are the components. States are present. State is nothing but a description of specifics of the location of 8 titles and the blank in one of the 9 squares. So where is 5 present, where is 8 present, where is 3 present, where are all these things present, that is called as states. Initial state is the starting state, what is present here. And actions means a block can move right, left, up and down, that are the actions possible. Okay, and the transition model, from one state to other state, when we go, what will be the model which will be specifying it. Okay, and goal test, it checks whether the state matches the goal in the configuration in the final state or not. And the path cost, to make each action, how much is the cost. Okay, and the components and well-defined problem in 8 puzzle. Okay, so 5 components are there. How many components are there? 5 components. In every question there will be 5 components. First is initial state, how it looks initially. Second is the goal state, how it should look finally. Third is the state space, means all the possible moves that can happen. Action means how many actions can happen: move up, move down, move left, move right. And path cost means what is the cost of each action, what is the cost for going up, down, right and left. Okay, that is the path cost. These are the 5 components present. Okay, and well defined problem in the 8 puzzle will be: initial state, goal test, actions, transition model, path curve, just as above which we discussed. That is the same thing as well-defined problem. Okay, so 8 puzzle is solvable using the breadth first search and A star search. Okay, next is explain BFS and DFS working and apply the same for the given graph. Okay, first we have to explain the working of BFS and DFS. Okay, this is the graph given, we will be having a look at it. First is breadth first search is a simple strategy in which the root node is expanded first, then all the successor nodes are expanded. Okay, means it will first explore all the neighbors, then it will explore the neighbors, and so on. It will keep on going like this. Okay, that is the breadth first search. Depth first search, it will go into the depth first, this node, this node, this node, this node, until it reaches an end. Then it comes back and again explores till the end. Like that it will go. That is a depth first search. So these are the steps given here for the BFS. You can go through it. And the DFS, all the steps are given here. Okay, the same thing what I explained, you have to write it in this steps form. Okay, next is apply BFS and DFS for the given graph. Okay, and one more thing, BFS use queue and DFS use stacks. Okay, what is queue? Queue is first in first out, and stack is last in first out, leaf 4. Okay, so we'll be seeing how do we solve this one. Okay, so in BFS, start from this node. Okay, this is the starting node, which is S here. Okay, S is the starting node. Okay, so I'll be writing here in the node S. Okay, and Q. In Q, what we will fill is the neighbors of S. S is connected with A and S is connected with D. So I'll be writing here A comma D. Okay, and BFS is what is visited. S is visited, so I'll be writing S here. Okay, now Q is first in first out. First in means A has come first, then D has come. So what is first, that will be taking it out also. Okay, first in first out. So A is taken here. Now A's neighbor. What is the A's neighbor? Only B is present. So D is remaining here and we'll be putting B here, and A will be taken into consideration here as A. Okay, after that the first in first out, right? So D will be taken and D will be first out. Now what are the neighbors of D? D's neighbor only G is there, so what we'll be doing is just writing G after B here. Okay, next what we'll be doing, after that again we'll be writing SA and D also came here. Next after that B is present here, first in first out. So B, what are the neighbors of B? Neighbors of B are C and G, right? So since G is already taken, we will be just writing C here. Okay, so we'll be writing C here, and B is also visited, so we'll be writing B after this one. Now G will be taken, and the neighbors of G, what are the neighbors of G? Neighbors of G are none, so we'll be not writing anything, so we'll be just writing C here. And since G is also visited, we'll be writing G after this one, and C is present here. Any neighbors of C which has not visited yet? No, only neighbor of C is G, which is already visited, so here nothing will be present, and C is also visited, so it will be C here after G. Okay, so this is the BFS final answer. Okay, next is DFS. In DFS we'll be using stack. Okay, again the same thing we'll be doing. Starting node is S, right? And all the neighbors of S, the neighbors of S are A and D, so I'll be writing here in the same way A and D. Now whatever is visited we'll be writing in DFS. Now it is last in first out. Last in first out means we have to take the last one and output it, so D will be taken into consideration here. Now neighbors of D are G only. Okay, so we'll be writing here G only. Okay, and since D is visited, we'll be writing D here. Okay, after that last in first out, G will be taken into consideration. Is there any neighbor of G present here? No, so we'll be just writing here A, and we'll be writing here G also. Now we'll come back to A here, and A's neighbor will be writing. A's neighbor is B, so we'll be writing here B here, and A is visited, so we'll be writing after this A. Okay, next after that we'll be taking B here. What are the neighbor of B? Neighbor of B is C and G, but G is already visited, right? So we'll be just writing C here. So since B is visited, we'll be writing B here, and C is taken here, and C's neighbor is G only, that's already taken, so will not do anything. Is used in depth first search, and BFS if FIFO is used. For any question you have to follow the same procedure. Okay, this is a super important question, don't miss this one. Next is explain iterative deepening depth first search. Okay, iterative deepening depth first search, let's have a look at it. So in iterative deepening depth first search, it is a combination. Okay, it is a combination of what? DFS and BFS. Okay, it repeatedly applies DFS with increasing the depth limits. Okay, it will increase the depth limits until the goal is found. At each iteration, it explores all the nodes in the current depth limit. So first it applies DFS, then at that level it will apply BFS. Okay, that is what IDDFS. Start at the root node, perform the DFS with depth limit of 0, increase the depth limit by 1, perform DFS again. Repeat until the goal is found or all the nodes are explored. Very simple, right? So solve the same maze problem where you start from AA and then reach to GG. Okay, this is the example which is given. Okay, this graph you have to make here, and the execution will be as follows. and the traversal order will be like this. First it will be AA, then it will go to the A B C D, A B C D, like that. At each level it will be exploring. Okay, first A it will be, then A B C D. After that, is the third level, E F G will also come into picture. Okay, so this is the thing you need to write for IDDFS. Okay. Moving on in the module 3, we have a lot about propositions. Okay, so you need to know a few concepts about propositions. I'll be telling you what all you need to know, and if you know those concepts, okay, you can solve a variety of questions. Okay, so pay attention to what I say here. So the first question is, which of the following are correct? Okay, so this symbol, you know, right? This is or. Okay, and this symbol is and this is not. Okay, that's it. Okay, these three symbols you need to know mostly, and this is nothing but it is implies. Okay, and this is bidirectional. I'll tell you what's the meaning of each of these. Okay, so which of the following are correct? They have given, that means A or B and not C or not D or E, okay, is equivalent to A or B. Okay, can we say if this is true means this is also will be true? Can we say that or not? Okay, see, in propositional logic, a conjunction means P and Q. Okay, if we consider this whole thing as P and this whole thing as Q, in this case it logically entails each of its component are true. Okay, that means if this whole thing is true means both of them must be true. That is what, if I say both of this is true means this is also true. That means this given thing is true here. Okay, like that, this is equivalent to this, like that it will be. Okay, and A or B is explicitly conjunct. Okay, the statement is logically valid. Next, A or B and not C or not D or E is equivalent to A or B and not D or E. Okay, what it's trying to say is we are excluding this C here and trying to form a conclusion that C is independent. Whatever the value of C is there, we are not concerned about it. It will still be equivalent. But is it true or not? We cannot necessarily infer that it is true because of the original clause could depend only on C alone. Based on only C, the whole clause can become true or false. Example we can take here, counter example. C is false, D is true, and E is false. Okay, let's take this example. C is false, D is true, and E is false. In this case, if C is false here, not C will become true, and not D will become false, and E is false. So this whole thing became true, right? Because or is there. So in between true and false, if or is there, means the whole thing will be true. Okay, not D or E. If both of these are not D is false and E is false. Okay, D is true, but not D will become false. False and false, it will become false. Now, if you observe, these both are not equal. Since the values of these both are same here, but because of only C, the whole answer became different here. So we cannot necessarily conclude that we can eliminate C from here. The answer could depend on C. It works in that way. Okay, so it is incorrect. Entitlement does not hold. Next, A or B and not of A implies B. If A then B is satisfiable. Okay, satisfiable means both are equal or not. Again, the same thing only. Now there are the rules of logic that I cannot explain it here. Those are present in the video of DMS. Okay, you can have a look at it. I have explained slightly there. And but if it is not there, also you can go through the notes. Okay, if you go through the notes or you can search in the Google rules of logic. Okay, there you will be getting some rules. First you learn that rules. Okay, then only come to this part. So if we go for the not operation for A implies B, it will be the negation of A or B. Okay, it will be negation of A or B, and since already not is here, if we apply not on not, it will become true. So true will be there and A will be taken, and or will become and when we take not inside. If you already know rules of logic, this you might already have got this. A and the not will come here and make it as not B, so it will be A and not B. Okay, so it will be A and not B here. Substitute A and not B in the place of this, so it will become A or B and A or and not B. Okay, so if A is true and B is false, if we consider A is true here, so this will be true, both will be true here, and B is false means this whole thing will become true, and this is true and B is false means this will become true, so the whole thing became true. That means the formula is satisfiable, means we are able to get true at the end. Okay, next, A bidirectional B, A bidirectional C has the same number of models as A directional B. See, if A B is there, how many things can be formed? 0 0 0 1 1 0 1 1, like that you can form 4. But if C is also there, for each of these we can have a 0 and 1 with C, right? C like 0 0 0 and 0 0 1. Next one, 0 1 0 1 0 0 1 1. For each of these 4 combination we have here 2 more combinations, so totally it will be 8 combination. So it is not same. It has just 2 models here, true true and false false, but if C also come, it will be true true true, false false false, and it will be extra character here, right? True true true, false false false. So the number of models possible can be increased. Okay, it do not has the same number of satisfying statement assignments. Okay, moving to the next one, we have consider a vocabulary with only 4 propositions A, B, C, D. Okay, and each can have true or false. So totally 16 possibilities are there. How many models are there for the following sentences, B or C? Okay, so total are 16, 2 power 4, and B or C. See, if B or C is there, the way in the only possibility where B or C will become false is B and C both are false, then only it will become false. If any of it is true, it will become true. So when these both are false, then only it will become false. And A and D are irrelevant, means we can have any A and D. A and D can be true or false, it doesn't matter. So total assignments are 16, and B and C, when it is F, in that case only it is false. So from 16 we can have such possibilities where A and D can be moved around. B and C are fixed, it is false. A and C can be true or false, so it can be true true, false false, true false, false true. So it will be total 4 possibilities. So we have to subtract 16 and 4, it will become 12. So 12 models are there, like that. Okay, now not A, not B, not C, not D. The only possibility where this is for true is when A, B, C, D are false. Okay, when it is false, then it will then only it will become sorry, when it is true, this whole thing will become false. Okay, we have to see when it is false. Okay, that's the criteria. So only one possibility is there, and we don't have any other variables to play with to change the variables. So only one possibility is there, so one will be subtracting from 16, it will become 15. Okay, and this one here, when it will become false, it will become false when A and A implies B. Okay, A implies B can be written as not A or B. Okay, as we discussed in the above problem, the implies can be written as this one. Okay, if it is written in a different form, this also has a law, there is a name for it. Okay, I forgot that name, but this can be written as not A or B. Okay, now if maybe it is modest tonus or modest ponus. Okay, I'm not sure. Not A or B. Okay, these two things are there. Now there is a not A and there is an A here, so it can never be false. Why? Because if A is there, it will become not A, will become true. If A is false, not A will if not A is false, A will become true. Like that, it will keep on altering and it will never become false. So it can it is called as unsatisfiable problem. Okay, where the contradiction is there, not A and A, this is a contradiction. Okay, so it will be unsatisfiable and cannot be solved. So there is zero models will be there. Okay, so those are the answers. Next, prove that if a heuristic is consistent, it must be admissible. Construct an admissible heuristic that is not consistent. So, what is consistent? What is admissible? In h of n heuristic, if it is admissible if h of n is less than or equal to h star of n. H star of n is the true cost from n to the goal. Okay, h of n is the estimated cost. This is estimated. This is true cost. Okay. Now, if it estimated is always less than or equal to h of means true cost, it will be admissible. Now, what is consistent? Consistent means if I want to go from one node n to n hash n hyphen, what is that? Okay, let's take n hyphen only, although it is not n hyphen. Okay, so n to n hyphen, if you want to go, what will be the cost plus what will be the heuristic cost directly to h of n hyphen, that will be greater than or equal to h of n. Okay, so and h goal is 0. If these two conditions are satisfied, that means h of n is consistent. Okay, now the proof is, let's take a node n, and the to the goal node we will be having n0, n1, n2 in between till nk. Okay, now h of n0 is less than or equal to c of n0 n1 plus h of n1. H of n1 we will be taking h of n2 till we will reach h of nk minus 1, it will reach h of nk, and we have assumed that h of nk will be equal to h of goal will be equal to 0. So we will be eliminating h of nk from here, so it will become h star of n naught, and this whole summation we will be writing it as from 0 to k minus 1. We have taken from 0 to k minus 1, so we'll be doing the summation. H of n naught will be less than this summation value, therefore h of n is less than or equal to h of n star. This whole calculation is equal to h star of n. Okay, so it is admissible. Every consistent heuristic is admissible. Now the reverse of it, admissible heuristic is not consistent. There exists some admissible heuristic which is not consistent. Now consider a state space where from you'll start from S, go to A, and then go to G. Okay, the cost from S to A and A to G both is 2. Okay, 2 cost is there. Now the true costs are 0, 2, and 4, right? From S to S if you want to go, it is Z. Sorry, from G to G you want to go, it is 0. From A to G it is 2. From S to G it is 4. Now if we define the heuristic such as, maybe it is means from G to G it is obviously 0. From A to G if we define it as 1, and from S to G we'll define it as 4. We'll check if 014 is less than 024. Yes, 014 is less than 024. Therefore it is admissible. That's the only criteria, right? The true cost should be always greater than or equal to the estimated cost. This is the estimated cost. Okay, so it is admissible. But let's check the consistency. If we check the consistency, check the edge S to A. Okay, so heuristic of S will be equal to cost of S to A plus heuristic of A. That is, the cost of S to A is 4. Sorry, the heuristic of S we have considered it as 4 here, right? So we'll take 4 here, and cost of S to A is 2, and heuristic of A which we have estimated is 1. So 2 plus 1 is 3, and we are getting an answer which is not right, right? This is inequality is violated. So therefore it is admissible but not consistent. This equality has to be satisfied for it to be consistent. So there is possibility where a heuristic can be admissible but it is not consistent. Okay, next, prove each of the following assertions. A is equivalent to B if and only if the sentence A bidirectional B is valid. See, if I tell you directly, A bidirectional B will only be true whenever A and B are same. If both are false, the whole thing is true. If both are true, the whole thing is true. Like that. So if both are false and both are true at the same time, that means A is equal to B. That's, it's as simple as that. Okay, so A bidirectional B is valid. Next, what is the next one? A is not equal to B if only the sentence A and not B is unsatisfiable. Okay, so let's have a look at it. So let's assume there exists at least one model in which A is true, B is false. If A is true and B is false, what will be the case? This will be true and this will also be true. It will be true, and therefore it is satisfiable. But if we take into consideration there exists a model where A is true and B is false, if we take it as false, false we will take, what will happen? The whole thing will become true. But B does not hold in all models where A is true. Okay, so A is not equal to B. A is true and B is false. We cannot say both are equal, but it is satisfiable. Okay, only when it is unsatisfiable, in that case it will be equal. Okay, that's the proof. Next, prove or find a counterexample for each of the following assertions. Okay, A is not equal to B and Y, then A is not equal to B and A is not equal to Y. So what it says is, if this whole answer is not equal to A, okay, in that case A is not equal to B, not equal to Y. It is not true. Why? Because see, this whole answer depends on either one. Okay, if both are 0, then it will be true. If suppose A is 1 and both are 0, then it is not equal. That's true. But what if B is 1 and this is 0? In this case still we'll get the answer as 0 only, because 1 and 0 if we do, we'll get a 0, and A is not equal to 0. But B was equal to A, right? So what I mean is, see, let's suppose B is true and Y is true. So B is true, Y is true means both will become 1. Now what if the value of A is also true? A is also true means A becomes equal to B and A becomes equal to Y. But this is both the values we are getting as true, right? So the conclusion is the assertion is true. Okay, next one is, if A is B or Y. Okay, if both it is equal, A is equal to this value, then A is equal to this and A is equal to this, or both. Okay, we cannot say this also. Why? Because see, suppose that we'll take A as A and B as true. Okay, we have taken P and we have taken P as true. Let's take both A and B as true and Y as false. Okay, now in this case, if A and B both are true, it will become true. This will also become true. This is false, but this whole thing will become true. So true will be equal to true. That is fine. But is A equal to B? Yes, both are true. But is A equal to Y? No. A was true and Y was false. It is not equal. So then the conclusion is, it does not entail both B and Y. Okay, so the assertion is false in this case. Next, different methods of deriving heuristics. Okay, there are how many methods are there? I think 4 are there. Okay, 4 methods are there to derive heuristics. Okay, heuristics is the nothing but H value. Heuristic is nothing but estimating the cost from given state to the goal. Okay, so different methods exist. First one is relaxed problem method. In relaxed problem, the constraints are relaxed of the original problem to make it easier to solve. The cost of an optimal solution to a relaxed problem is used as a heuristic value. Ignore the obstacles in root finding problems. Suppose that there are some obstacles in between my way to reach a goal. Okay, so if I don't know how much time it will take me to solve this obstacle, but if you ignore this obstacle, I can estimate like it will take 1 minute for me, so I'll take 1 minute as the heuristic value. Okay, problem decomposition method. The original problem is divided into smaller independent subproblems, and those costs are combined at the end. Okay, solving individual tile movements in eight puzzle problem. Pattern database model. Pre-computed exact solution cost for abstracted states are stored in the database. Using those abstracted states which are stored in the database, we will be calculating the what is the cost going to be now. Okay, like that. From the previous values, we are trying to estimate the future value. Okay, pattern databases for sliding tile puzzles. That's the same example here. And learning-based method. The heuristics are learned automatically using machine learning or experience from previous problem-solving episodes. Learning heuristics in game-playing agents. Okay, so that will be based on the previous experience it will be learning and solving the next problems. Okay, next, explain in detail syntax and semantics of propositional logic. Okay, these are 10 marks questions, so you have to write about syntax 5 marks, semantic 5 marks. So what is syntax? Syntax defines structure and formation of rules of a well defined for well formed formulas in propositional logic. So let's take the propositional logics, like for example symbols will be there, p, q, r, a, b, c. These are the symbols. Each symbol can have either true or false. Okay, each represents true or false. Now the connectivities, which is negation means not of something, conjunction means and, p and q, disjunction means p or q, implication means if p then q, bidirection means if p then, if and only if p is true, then only then only q will be true, if and only if. Okay, so these are the 5 things you need to write. Okay, for logical connectives. Next is formation rules. So if p is a sentence and not p is also a sentence, every propositional symbol has a sentence, is a sentence, and p and q are sentences, then p and q, p or q, p implies q, p bidirectional q, all are sentences. Parentheses are used to remove ambiguity. Means, see, if I write 1 plus 2 minus 3, okay, if I write a bracket here, we'll be knowing first to solve this, then do the subtraction. But if I write 1 plus 2 minus 3 without a bracket, we'll be confused like what we have to do, this first or this first. In this case, it is answer is same in both cases, but I'm giving an example. Okay. Next is semantics of propositional logic. Semantics define the meaning and truth. So if you write a sentence which is meaningless, C is equal to C, this is meaningless sentence. Why you are writing it? So semantics define the meaning and truth of the sentences. Means whether the sentence given is true or not. Okay. So how do we do it? If not p is true means p is false. Okay. So if we consider not p is also true and p is also true, what is the point of defining this? There is no point. The point thing is defined by the semantics. Okay. If not p is true means p is false. If p and q is true means both p and q should be true. Then only it will be true. Right. That is a true table of Boolean algebra basics. Right. And p or q is true means at least p or q is true, at least one of them should be true. That is a requirement. Okay, implication, if p then q means it is only false when p is true but q is false. Okay, rest all cases it will become true. Bidirectional means p and q both are true or both are false at the same time. Okay, it should have the same truth value. Next, logical concept satisfiable. A sentence is satisfiable if it is true in at least one model. It is unsatisfiable if it is false in all the models. Valid tautology means all the sentences are valid if it is true in all models. Entailment means every model that satisfies A also satisfies B. Okay, whatever the value of A is there, it satisfies A, then it should also satisfy B with the same values. Okay, the conclusion is syntax specifies how sentences are formed. Semantics specify how sentences are interpreted and evaluated. Means truth and false values will be assigned to it. And heuristic function explain A star search algorithm. This is the most repeated one in the module 3. Okay, for minimizing total estimated solution cost. Okay, then you have to also apply the A star search for this following graph here and find out the answer. Okay, two types of question they can ask: theory. If they ask the theory, you have to write this one. If they ask the numerical, you have to write this one. Let's discuss each one by one. Firstly, before that, they had asked what is heuristic function, right? So the definition will be as follows: heuristic function in artificial intelligence is a mathematical function used to estimate the cost of reaching a goal state from a given state. Okay, from one point to other point, what is the cost? Okay, that is the heuristic. It serves as a guide for search algorithm to make decision about the which paths to explore, improve efficiency by prioritizing more promising options. Okay. Next, what is the A star search? Minimizing total estimate solution cost. Okay, so some theory concepts are given here. I'll be not going through it. I'll be directly solving the problem so you understand what is written here. Okay, if you want, you can go through this one. After understanding, you can write it in your own words also. Okay, so moving on to the problem here, a few things you need to understand. Okay, let's take it each one by one. So the first thing you need to understand is this is the graph given, okay, and what are the nodes present? The nodes are A, B, F, Z, and all those are nodes. And whatever is present below the nodes, that is the heuristic cost, okay, that is the heuristic cost or the node cost. And what is whatever is present in the number as the beside the line, that is the edge or the edge cost, okay, that is the reachability cost, okay. So the formula you need to write is cost is equal to edge plus node. Whatever is the edge cost plus the node cost. Suppose that I want to reach from A to B, okay, what will be my cost? If I ask you, you should say that it is the edge plus the where you reach that cost which is present here. Wherever you reach the node cost of that, okay, not this cost, you have to take the destination node cost. So to reach from A to B, my total cost will be 4 plus 12, which is 16. You got the point, right? So here we have to maintain two lists, open list and closed list. Open list will contain all the nodes which are not yet visited, and closed list will be containing all the nodes which are already visited, okay. So the not yet visited here and visited will be here, okay. So let's get started with this one, okay, the calculations again. Okay, for simplicity purpose I have taken the same thing here as well, okay. So now first we'll be starting with A, okay. As you can see here, A is present. From A I have two options, I can go to B or I can go to C, okay. What is my cost from A to B? From A to B, my cost will be 4 plus 12, okay. My cost will be 4 plus 12. What is 4? 4 is nothing but the edge cost, and 12 is nothing but the node cost where I'm reaching the final node, okay. So this will be equal to 16. Next I have the option from A to C, I can go, right, A to C. So what will be my cost from A to C? From A to C, my cost will be 3 plus 11, that will be 14, okay, right, it will be 3 plus 11. And from A I have two neighbors which is B and C. So in the open list I'll be writing here B and C, okay, and I'll be removing A from here, okay. This will be continuously updated. Closed list is the one which is visited, and open list is the one which we have to visit. So since A's neighbors were B and C, it's not yet visited, I've put in the open list. A is done, we have done with the calculation of A will be in the closed list, okay. So now after that A I can go to B and C. You have to choose the lesser one, okay. Lesser one is 14. So AC path will be selected. Now AC I will be writing it directly here, and the cost of AC is 3 and 11, okay. Now from AC, where I can go? From C I can go to E and D, right? So I can go to E and I can go to D also. From A and C I can go to D also, right? So if I go to E, from AC, if I go to E, what will be my cost? My cost will be 3 plus 10 plus 4, okay. This part you have to ignore because we are directly going from A to E, okay. This 11 is the intermediary, you have to ignore. Now we will be considering the E's node cost, okay. So it will be 3 plus 10 plus 4. What is 3 plus 10? It is 13. 13 plus 4 is um, 17. So this will be 17 here. If I go to AC and D, what will be my cost? 3 plus 7 plus 6. So that is equal to 10 plus 6, right? It is 16. Now again we will be selecting which is the least one. Least one is 16, right? So we'll be taking 16 into consideration. Now 16 if we take into consideration, it will be ACD, right? From ACD, where I can go? From ICD only one option is there, I can go to E only, right? So what will be my cost? My cost will be 3 plus 7 plus 2 plus 4, okay. 3 plus 7 plus 2 is 12. 12 plus 4 is 16, right? So again I have got 16 here. This is the least one. Still it's the least one present. And finally from E, where all I can go? I can go to B and I can go to Z also. But if I go to B, if I go to B, right, what will happen? If I go to B again, from here it will be 12 plus 5, it will be more. The common sense is I have to reach Z, right? Shortest path is this one. So I'll be taking this one, 5 from here, okay. So if I directly take A, C, D, E and Z, what will be my cost? A, C, D, E, and directly if I go to Z, what will be my cost? It will be 3 plus 7, 10, 12, 12 plus 5, 15. Okay, and the heuristic cost for Z is not given, so it will be considered as 0 only. So the final path which I have to, which I'll be getting is the following path. Okay, it will be actually the 3 plus 7, 10, 10 plus 2, 12, and 12 plus 5 it is 17. Okay, not 15, it will be 17. Okay, so this is the final answer here, and this is the minimum cost. Okay, total it will be 17. Now in meanwhile you have to explore the other nodes also. From B also there were possibilities, right? F and E also you could have gone, okay. So by doing while you are doing this, you have to maintain the open list and the closed list as well. Okay, wherever you visited, B and C was visited, right? So B and C has to be removed. B is visited and C is also visited, and the neighbors of B and C has to be written here. Neighbors of B and C are what? Neighbors of B and C are F, E and D, right? So we'll be writing here E, D, F. Okay, E and D also got visited, so we'll be moving E here, and E's neighbor was Z here, right? And D is also visited, so we'll be writing D also here. And F is not yet visited, so we'll be visiting F also. Now how do we visit F? B is present here. From B we will go to F and E. Okay, now the same thing will be writing here. If I take the option A, B, I can go to F, and from A, B I can go to E also. Okay, there are two options here, but this will not be the minimum cost. My minimum cost will be this only. Okay, there will be, this is the least cost which I have got here. Okay, because I have taken the least list at each point, so this is the least cost, and this is my final answer. But you have to explore the other nodes also. Now we'll be exploring this one also, A, B and F. Okay, so if I want to go to A, B and F, what will be the cost? 4 plus 5 plus 11, that is equal to 9 plus 11, that is equal to 20. See, 20 has come already, it is increased, it is still in F but it is increased still. Okay, if I go to A, B, E, it will be 4 plus 12 plus 4, that will be 16 plus 4, that is equal to again 20. In both of these cases 20 is there. If you want, you can write this one or you can skip also. Okay, because all the nodes are already visited, you will be putting this also in the closed list. Okay, so that you have to make after each step here. Okay, what is the status of open and closed list? Okay, then only you can expect full marks. In the question itself they have given, if you don't write it in the means the status of closed list and the open list each time, you can lose the marks also. See, write all steps as well as the open and closed list for full marks. For explanation purpose, I have just given you a one single list and updating here only, but in exam you cannot erase and update in like a live video, right? You have to make it again and again. Okay, then only you can get full marks. Don't worry, it's not a very difficult thing, just will take some time, but the time is worth it. Okay, it is 10 mark question. Okay, so don't miss this one. Moving on to the next one, we have with a neat diagram explain knowledge based agent. Okay, this is another type of agent which is called as knowledge based agent. Okay, and the algorithm associated with that. Explain the tell and ask functions used for the same. Okay, what is a knowledge based agent? So logical agents are always definite. It will be based on the proposition, it will be either true or false. But knowledge representation, it will be understanding the world. Okay, it will be understanding its environment. So there are two approaches for this one: declarative approach and procedural approach. And the sentence is also used here. Okay. So knowledge base is a set of sentences describing the world. There will be a set of sentences in knowledge base which will be describing the world. Okay, that is the knowledge based agent. It will have the background knowledge. The knowledge level will be specified. Tell is nothing but a function that adds knowledge. Ask is nothing but it queries the agent about the truth of that knowledge. Okay. Ask is nothing but true or false answer will come, and tell means adding the knowledge. Okay. Inference is the process of deriving new sentences from the knowledge base. Whatever the existing sentence is there, you are deriving a new sentence. This is the algorithm you have to write here. So the function name is KB agent percept, and it returns an action. And persistent KB a knowledge base, and T is a counter which is initially 0 indicating time. So T is a time and KB is knowledge base. Now first we will tell. Okay, and the parameters passed will be KB make percept sentence, and percept and T will be passed here, and action will be returned with the ask statement. Okay, we'll be asking the truth of the particular query, and that will be stored in action. Okay, like that similarly it will be done for the action as well, like how we did for the percept, and T will be T plus 1 means for the time will be increased. Okay, and the action will be returned. Okay, so this is the architecture they are also asked in the question, make a neat diagram. So this is the diagram you need to make. Okay, environment is here, input from the environment, and output will be taken. Before that, knowledge base is referred with the inference engine. Okay, and learning will be happening at in between. Okay, this is the knowledge based agent diagram. So that same thing is also given here. You have to write these points as well. Okay, moving on to the 10th super important question, which is explain WUMPUS World problem in detail. Okay, this is a very interesting one and easy one. Okay, so you need to understand few concepts here. Okay, so see here, this is the diagram you need to make. Okay, 4 cross 4 matrix, and here the first thing you need to understand is this is the agent, and agent has an arrow. Okay, you understand this is a story. Okay, agent has an arrow and is standing here, and in the WUMPUS world there is a pit. Okay, pit means if you go into the pit, you will be falling and dying. Okay, and wherever pit is there, in the down, left, right and up, there will be breeze. Okay, breeze will be nothing but a cold air. Okay, so since down part is not there, it will be present here, here and here. Okay, that will be the cold breeze. Wherever pit is present in the all the direction, the north, east, west, south, it will be breeze. And wherever a wumpus is present, wumpus is nothing but a monster. Okay, there will be smell present here. This is smell here, smell will be here, smell will be here. Okay, now the rule is that the this person wants to go to this path and take the gold from here. Okay, see, this is the gold. Okay, he has to take the gold and come back from where he has come. So avoiding the pits as well as the monster, he has to avoid. That is the rule. Okay, that is the rule. And he can go either top, left, bottom or right. He cannot go directly into the vertical, means a diagonal. Okay, that is the rule. Now he can hit the arrow with the to the wumpus, so wumpus will die. There are some points associated with that. Okay, so the working will be as follows. Okay, working, what it will be doing is how he will ensure that he has taken the gold and come back to his place. Okay, so for that what he will do is he will first go here. Okay, he will first go here and there will be breeze. Now if breeze is present here, the pit might be here or here, right? He doesn't have knowledge what is present here and here, but since breeze is present here, if pit is present here, breeze can be here. If pit is present here, breeze can be here. Two possibilities are there. So he's a scared person, he will come back here. Okay, now he knows that the breeze is present here, means they can be pit here and here. Next he goes to this place. In this place he gets the sting. Okay, sting means bad smell. If bad smell is present, he will understand that there is a wumpus here or there is a wumpus here. So either of these places wumpus can be present. Okay, so what he does is he will analyze. If wumpus is present here, there will be no breeze present here, because wherever wumpus is present, breeze will be there will be smell also, but there was no smell present here. If there is no smell present here, that means wumpus cannot be present here. That one he will be thinking and using his intelligence and finding out. So he'll get to know there is no wumpus present here, but there can be a pit present here. But pit is also not present here, because if pit was present here, there would have been breeze here. So since breeze is not present here and the stink is not present here, there is neither pit nor wumpus present here. He will make a decision to go here. After he goes here, he will go to the top and he'll get the gold. If he does not go to the top first, he'll come here and see if there is breeze. So breeze means there can be a pit here or here, so he'll come back here and he'll explore this path. This path he will get the gold, and again he'll come back to the same to the starting position. Okay, this is the wumpus problem. And the same working, whatever I told you and all the concept which I told you have to write in the exam sheet. The same thing is given here also, you can go through it. Okay, here also we have to write the piece description. PEAS, performance, X environment, and AS is actuator and sensors. So these are the performances: 1000 for climbing, -1000 for falling into the pit, -1 for each action taken, -10 for using up the arrow, and game ends if the agent dies or agent climbs out of the cave with the gold. Okay, environment is also given. It's a forecast for grid of rooms, and it can have a wumpus who is smelly and the pits are breezy, and the same square if the gold is present. And shooting the wumpus kills if you are facing it, and shooting uses only one arrow which is present. So these are some of the things. You can go through it. You have to write this in the piece descriptions. Okay, and the actuators mean you can go to the top, left, right and down, and you can grab the gold and you can climb and you can shoot. Okay, and the sensors are also given here. What are sensors means? The agent can sense the pit and the breeze and the stink, and you can shoot the wumpus. All those things you have to write here. Okay, this is all about the WUMPUS World problem. Very important one, don't miss this one. Okay, moving on to the module 4, we have the question which is to find out if these statements are valid, necessary or not, necessarily valid true statements or not. Okay, so there are three of them. We have to discuss each of these. Okay, so the first one is for some x. Okay, this symbol denotes for some and this denotes for all. Okay, for some x, the value of x is equal to x, and for all y, and inside that for some z, the value of y is equal to z. We have to prove if this is necessarily true or not. Okay, means whenever this is true, this will also be true. We have to prove that. Okay, x is equal to x is true for any object in the domain, so this will always be true for sure. Okay, and this might be true, or sometimes it can be true, sometimes it can be false. But if and only if x is true, then only the domain is non-empty. And in the first order logic, the domains are assumed to be non-empty. So this is non-empty and it will always be true. This is guaranteed for sure. Now for any object y, choosing z is equal to y satisfies y is equal to z, right? If we choose z is y, this obviously means y is equal to z. Therefore this will also be true. Therefore when this is true, this will always be true. The valid it is necessarily, the statement is necessarily true. Okay, the next one is for all x, p of x or not p of x. See, For all x, the p of x value can be either true or false, right? And there is an or in between, so it will always be true. True or false is always true, so it is valid, which is necessarily true. Next, for all x, a function which is smart x or x is equal to x, either this is true or this is true. See, this one is always true, right? So we can ignore this one, whether or not it is true, I don't care. But this is always true, that means it is valid, necessarily true. Okay. The next one is write unification algorithm, explain with a suitable example. Okay. Unification is the process of finding a substitution that makes two logical expressions identical. Okay. Substitution process is called most general unifier. Okay. So the pseudocode is as follows: unify x, y, and 0. Okay. These are the two things we need to substitute. So if 0 is failure, then return failure. If x is y, then return 0. If variable x, that means return the unification variation of x, y, and 0. If it is y, variable is y, then you return the verification of variable of yx0. Okay. And if it is compound x and compound y, then return the unified arguments of x and y, and unify operation x, operation y, and 0, else return failure. Okay. And if it is a variable n x, if variable belongs to 0, then unify 0 of var x and 0. If x belongs to 0, then unify var x and 0 of x and 0. Occurs check if var and x, then return failure. Okay, all you need to all you need to do is write something similar to it. Okay, you need not write exactly as it is, there can be many codes. Okay, so the main thing is you write something similar to it. You have to write the unification variation function here, and if it is failure means return failure. If it is y equal means then return 0. If it is x means return xy0. If it is y means return yx0. If it is compound means return arguments and with unified operation of x, y, and 0. And here we have var, so we will be writing if var belongs to theta, if x belongs to theta. Occur check if var of x, return failure. And finally return 0 union var or x. Okay, just write something similar to it. You might expect at least more than 50% of the marks for this. Okay. Explanation: if both expressions are identical, no substitution is needed. That's why we are returning 0 there. If one expression is a variable, bind it to other expression. If both are compound expression, recursively unify the operator and argument. That's why it was having arguments here, right? Argument and operators here. Then we have to recursively unify both of them. Occurs check prevents infinite substitution, means we are checking if it's already done, we are returning failure. Okay. Next example of unification: x and fy, a and fb. Okay, we are trying to unify it. Okay, p is equal to p, predicate symbols match. Unify the arguments x with a substitution x by a, and fy with fb means y with b substitution y by b. So if we substitute, it will be x by a comma y by b. That is nothing but a and fb. Okay. So conclusion is, unification algorithm systematically finds substitution to make expression identical. It is a fundamental operation in the first order logic, resolution, and logic programming. Okay. The next one is simple forward chaining algorithm. Okay, it's very quite easy to understand. Forward chaining is a data-driven interface algorithm used in propositional and first-order logic. It starts from a known fact and repeatedly applies inference rules to derive new facts. Okay, there is some known fact and will apply the inference rules to derive new facts from it. Okay, until a goal is reached or no new facts can be inferred. So initialize a knowledge base with all known facts. Repeat, and what you have to repeat: find a rule whose premises are all satisfy the current set of facts. Find a rule and add its conclusion to the knowledge base if it's not already present. So we are using the rules to identify a fact which is not already present and then adding those facts. Okay. And stop when a goal is derived or no new facts can be added. Okay. So this is the pseudocode for it. Forward chaining, this is knowledge base and this is goal. Inferred set, initially it will be empty. Agenda will be set of known facts. Okay. While agenda is not empty, apply the rules in the agenda to find if there is a goal, then return true. If it is not a goal, then add p to the inferred facts. Okay, for each rule check if it is already there, then decrement the count of satisfied premises. If count is 0, add q to the agenda, and finally return false. Okay. If you take an example, a and b are the facts. Rules are a and b derive c, c derives d. So obviously we have a b, we will be doing and operation, will get c, from c we will get d, like that. Okay, so goal d is reached. So conclusion is, forward chaining derives conclusion by progressively applying rules to known facts. It is effective when all relevant facts are available and goals are not known in advance. So we'll be deriving the rules and reaching to the goal. Okay. Have explained the syntax and semantics of first order logic. Okay, so there are some things you need to understand in first order logic. So what is a sentence? Sentence is nothing but it can be either atomic sentence or complete sentence. Now what is an atomic sentence? What is a complex sentence? Atomic sentence will have predicate and predicate with the terms. Okay, and complete sentence will have a sentence followed by an optional sentence. Okay, or it can be a negotiation of a sentence, or an and of sentence, or of sentence, and conclusion of sentence, bidirectional conclusion of sentence, or it can be called quantifier variable or any other sentence. Okay, and term can have function, constant of constant or variable. Quantifier is for all and for some, and constant is the following, the single names. So can variables are the following here. The variables can vary in the values. Predicate can be true, false, after love's raining, and the function can be mother, left leg. So whatever the task which are to be performed will come in the function, and predicate will determine if it is a true value or a false value. Okay, and the operator's precedence first will be first consideration will be given to the not operator, followed by an equal operator, and this is an and operator or operator. This is the conclusion operator. This is the bidirectional conclusion operator. So these are the syntaxes present in the first order logic. Okay, these are the syntaxes. Next, there are semantics also. Semantics means meaning. Okay, semantics of first order logic means meaning of the expressions. Okay, let's have a look what are the meaning of the expressions. So some key components are there in the semantics. First is domain of discourse. Okay, all objects set with the variable FOL can range. Okay, in a statement about people, all the set of humans can be a domain. Okay, and interpretation means what is the meaning of it. Okay, constant symbols and predicate symbols, as well as functional symbols. Logical connectivities, and, or, not, right arrow, left arrow, all those things. Okay, quantifier means some, for some or for all. Variable assignment means each variable is assigned an object from the domain, and the meaning is depending on these assignments. Okay, and evaluation of statements in FOL. So there can be evaluations as well. It depends if it's an atomic sentence, complex sentence, or quantified sentence. Okay, based on that, there will be evaluations present. Okay, and a few examples also there. This is just for the understanding and go through it. But from the exam perspective, it is sufficient to just write the theory part above. Okay. So this is the same thing. We are just applying to some examples of the particular domain, like 1, 2, 3. Here it's a domain. What are the constant symbols 1, 2, and 3, and the letters will be mapped, and predicate symbols will be there, P of x, Q of x, and so on. Okay. The next question is explain the steps involved in knowledge engineering with example. Okay, so there are 7 steps involved in the knowledge engineering. Okay, let's have a look. So the first step is identifying the task. Okay, knowledge engineering means how do we gain knowledge? Okay, first we'll identify the task, the problem which is to be solved, or the knowledge which is required. Okay, understanding the domain where it is present and what are the requirements of the domain. That is the first step. Okay, example, building a medical diagnostic system to identify disease-based symptoms. What we want knowledge in. That is the first thing you need to identify. Acquire the domain knowledge. Get to know the knowledge from the domain experts, research papers, databases, and past experiences. It includes interviews, observation, and data mining. Okay, consult a doctor and medical literature to gather rules about the symptoms or the diseases. Acquire the domain knowledge. Third is representing the knowledge. Organize and structure the knowledge and represent it in the form of rules, frames, semantic network, and ontologies. Okay, the relationship between two or more terms. Okay, for example is represent the disease and symptoms using rules. If fever and rash, then measles can be the disease. If fever and sore throat is there, then strep throat will be the disease, like that. Okay, choose an interference mechanism. What will be the mechanism used for interfering? If this are there, what it will be the conclusion will be depending on which mechanism we use. Okay, so if it is forward chaining, there will be some conclusion. If it is backward chaining, we'll be using, there will be some other conclusion. Reasoning with uncertainty, there will be some other conclusion. So which is being used, we have to find out which is the best in this particular scenario. Okay, next is implement the knowledge base. Okay, encode the structured knowledge into a system using programming languages. Use the tools or the expert system shells, and then implement the knowledge base. Test the system, validate if it is performing right or not given the answers, and define and maintain. Okay, that is 7 steps we use for acquiring the means the in the knowledge engineering. Okay, example is given here for the medical diagnostic expert system. Here task is to diagnose the disease, acquire the knowledge from the medical textbooks or from the doctors, make some rules here, and choose the inference mechanism, and write the knowledge base using the programming language Prolog. Test the system and reference and maintain the system. Okay, that's all from the module 4. Moving on to the module 5, we have explained backward chaining algorithm with an example. So what is a backward chaining? By the name itself you can understand this algorithm works from backward. Okay, from the goal to the start state. Okay, if we want to reach our goal, first we'll start from the goal. If you want to reach to the last state, how do we reach the second last state? How do we reach the third last state? Like that we'll keep on going backwards. Okay, that is called as backward chaining. Okay, and here we'll be having the knowledge with whose base is head, which unifies with the goal, and each new recursive call present in the body will be added to the goal stack. Okay, it will be solving the stack one by one to reach the goal. Okay, so this is the code part of it, the algorithm. You can go through it. And here the example is given. Okay, the criminal west example is given. American weapon, and the west sells the weapons here, and the hostiles are present here, and the weapons can include the missiles, and selling can include the missiles, and owning and the hostile can include the enemy, and so on. Okay, so this is a simple example. You can make your own example as well. So this is what the backward chaining is. Okay, first we will be starting from the back. If criminal west is criminal, what is the possibilities? It can be either through the country, or through the weapon, or through the selling, or through the hostile, and so on. Okay, and we'll be tracing back where it has started from. Okay, this is what is called the backward chaining. To prove criminal west, we have to prove the four conjuncts below it, and to prove the four conjuncts below it, we'll have to proving the sub conjuncts below this one until we reach the start state. Okay, and for that we'll be using the logic programming. Okay, Prolog is the programming language used for defining the logics. Okay, it has some syntaxes, like for example here the syntaxes you can see here, like this we'll be writing, and there will be some functions also performed, like the appending functions, and sets also will be maintained here. And efficient implementation of the logic programs, we will be using some algorithms which are designed to maximize the speed. And constraints in the logic programming, what all we can do, what all we can get the answer for, and what all we cannot get the answer, those constraints are defined here. Okay, means some query will be there, but it works fine, but the query like a triangle has no solution. Some of the inputs might not have any solution, so those are the constraints also we need to define. Okay, so that was about the backward chaining. Moving on to the last important question of the AI, which is explain the concept of resolution in AI. What is resolution? Resolution is a rule of inference. Okay, means we are inferring something. If a person has worn the sunglasses, the person is cool. Like that, we are inferring it. Okay, that is called as inference. For the propositional logic, if A and B are true, the answer will be true, the final answer. If A, B both are true, the final answer will be true, like that. Okay, and first order logic also will be using. It is a powerful method for automated theorem proving and plays a critical role in system like logic programming. To determine if the state of statements is logically consistent or not, it can prove the statement by contradiction. It can be converted into conjunctive normal form, which is a conjunction of disjunction. Okay, if two clauses contain complementary literals, they can be resolved by eliminating those literals. General form is given here: A or P, not A or Q, and given that P or Q is true. Okay, if you want to prove A, if A is true, then definitely C will also be true. A is inferring C. The premises which are given are A or B both are true, and not B or C both are true. See, the common sense is here: if A and B both are true and not B is also true, how can not B and B both true? If not B and B both are true, means it will be false condition, so we'll not consider B here. In this case, A and C both are true, like that we'll be getting. Okay, so to conclude A goes to C, we can use the disjunction formula to make it in this form: not A or C. Okay, and if you take the not operator on the top of that, we'll be getting A or not C, A and not C. Okay, and we have the initial set of clauses here: A or B, B or not B or C, A and not C. All of these are true. If you apply the resolution one by one, resolve A and B with A. Okay, means A and B is present with A. If we take, it will give us the conclusion that B is true. Okay, so result is B. If we resolve B with B and C, we will get the result as C is true. So we have got the result B and C both are true. And if we resolve C with not C, that means it is an empty clause. If C is true, not C will be false. But if both are true, means it will be an empty clause. Okay, so by using these logics, we will be able to give the conclusion that if A is true, then definitely C also must be true. Okay, to backward chaining and forward chaining. Okay, so give an example, give a backward chaining proof for the sentence 7 is less than 3 plus 9, show only the steps that lead to success. The same way we have to give a forward chaining proof for the sentence 7 is less than 3 plus 9, show only the step that leads to success. Okay, so the goal is we have to prove 7 is less than or equal to 3 plus 9. So first take 3 plus 9, it is equal to 12. New sub goal is 7 is less than 12. That is true because of the axiom A is less than or equal to B means B is a natural number greater than A, and the statement is true. Therefore 7 less than 12 is true. Therefore 7 less than 3 plus 9 is also true using backward chaining. Forward chaining, 3 plus 9 is 12, 3 plus 9 is 12, and numerical ordering, 7 is less than or equal to 12. Substitute 12 back, then we will get 7 is less than or equal to 3 plus 9. Therefore 7 is less than or equal to 3 plus 9 is proved using the forward chaining. Okay, so it is proved both using backward and forward chaining. Next is illustrate the procedure to convert a sentence of first order logic to CNF. Okay, this might look a little bit complex, but it's not. Okay, a sentence is in CNF, which is conjunctive normal form, if a conjunction of one or more clauses where each clause is a disjunction of literals. Okay, we are doing a conjunction of disjunction of literals. Okay, so the first step is to eliminate the implications and biconditionals. If it is in this way, we have to write it in this way: p or q, not p or q. Bidirectional will be replaced with not p or q and not q or p. Okay, this is the rules are there, like how we do the substitution. Okay, in that way, the if we have to convert the bidirectional and implies to the operators of or and we'll get the following answers. Okay, next is move the negation inward. If there is a negation here, move it inward, means take it inside of the bracket. So if we take it inside of the bracket, according to De Morgan law and double negation, not will come to p and q, so it will become not p and not q, but and will turn to or. Okay, and the same goes for this, and if you take this also inward, it will become for some. And if we take it inwards or for some, it will become for all here. Okay, so it will get reversed. The third rule is standardize variables apart. Rename the variables so that each quantifier has a unique variable. We should not have duplicate variables. Move quantifiers to the front in pre-next form. Reorder the quantifiers so that all quantifiers appear at the beginning of the formula. Okay, we cannot have something like x is here and then it will be for all. Okay, for all cannot be after x, it should be for all x, it should be like that, not x for all. Okay, eliminate existential quantifiers. Columnization. Columnization means if there is no universal variable exists, column the constants. If there is dependent on universal variables, column the functions. Okay, drop universal quantifiers. After all columnization, remaining variables are universally quantified and can be omitted. Then distribute and over or over and. Okay, so if you take an example, for all human of x, for some y, love of x and x or y. Okay, first is to eliminate the implication. Implication is this one. We'll convert this into or and we'll be taking the negation on both the sides. So we'll be obtaining this one. Okay, means not on both the sides. P implies q is nothing but not p or q, right? So not p will be implied here for not human. Okay, and move quantifiers in pre-next form, so we will be taking this outside. Okay, and columnization, y depends on x, right? Because see, this is y and this it depends on x. See, this y is present here and depends on for all x some y, so y depends on x, so we'll be writing y as f of x. Okay, and dropping universal quantifier, we'll be removing this one, so we'll be getting human of x or love of x comma f of x. Then final will be writing the same thing again here, which is not human of x or love of x comma f of x. This is the converted CNF form. Okay, next, illustrate categories and objects with suitable example and explain the following with respect to events, time, and fluents and objects. Okay, categories and objects. What is categories? It is nothing but groups or classes which share the common properties. If category is vehicle, the objects are car, bus, bike. If it's animal, dog, cow, and cat. If it is person, it is Alice, Bob, and John. If it is objects, objects are nothing but individual entities. Car one and the person named Ali, and dog one, it belongs to animal, like that. Okay, so categories represent classes or objects, and objects represent individual instances. Okay, an explanation of respect to events. Time is defined with respect to event. Time is used to represent when an event occurs in the or the order of events occur in which way, that is denoted by time. Okay, it allows reasoning about the changes in the world, and it represents discrete time points in continuous intervals. Events occur at specific time points and cause changes in the state of the world. Switch on at time t5, and the light on becomes on after time 5. Okay, fluents are properties whose values can change over time due to events. For example, light on room, we are oning the light for what? Room. We are opening the door for room. We are locating person, like that. Okay, the truth value of fluents depends upon time. On that particular time, what was the value? Objects are entities that participate in the events: person, room, light, door. The relationship between each of these is events act on objects. Events cause fluents to change the truth value over time. event open door. If it is open door, the object is door, and what is the event which is happening? Opening of door, so door open, and on which it is happening? On door, like that. Okay. Time provides a framework for ordering events. Fluents describe changing properties, and objects and entities affected by events. Okay. Together they enable reasoning about dynamic systems in AI. That's all for the video. If you found this video helpful, please like and subscribe. It helps me make more videos like this. And thank you so much for watching. Don't miss any of these questions. I'll see you in the next one.